Hello, everyone.
Hi, Professor.
Hello.
Hey,
Hello.
how's it going, Professor?
Good, good. How are you?
I'm doing well, thank you.
I'm
Great.
doing great.
So this is a review session for exam one. I will go over the materials that will be covered in exam one. The exam will cover chapter one, chapter two, chapter three. So chapter four will not be in the exam. And I have just finished the exam. It is 5 questions. The first questions are short answer. You don't need to give me explanation. That short answer for question one and question two. And then question three has how many parts? Has 3 parts: ABC, calculation, interpretation, and also question four has A, B, C, D, E, F, G. So this is the longest one. Also interpretation, calculation, and these kind of things. And question five is AB, only 2 parts, and then bonus question with 3 points. So the total will be 50 points plus 3 points. You can get 53 out of 50. So the bonus question should be easy one, very easy one. Do not overthink the question. Okay. Any questions?
We're gonna have to do like by hand calculations or are they calculations
Yeah.
from R?
Yeah,
Okay.
both. So I will give you some output from R, like numerical summary or graphical summary or whatever, or ANOVA table or whatever, and ask you about this numerical summary. So you can use this numerical summary to do some calculations, or if the question asks about something and it is given, do not calculate it. So do not calculate anything is given. Okay. Any other questions? So you need to bring a calculator. I uploaded some guidelines for the exam and uploaded to Canvas. So please read these guidelines before you come to the exam. Any other questions?
Professor, can you go over like the T alpha? Just when we get like the T alpha, for example, it's when we're doing 95% confidence interval, it's gonna be 0.05 over 2. So
Yeah,
0.025, right?
yeah.
And then let's say, for example, we want to find there's 0.025 and then comma, let's say 18. Is it's gonna be different when we
So
find.
you go to the T distribution table and find 16 first column, degree of freedom, alpha over 2 first row, and the intersection is the T value that you need in the confidence interval. I will go over this one. I will go over everything in chapter 1, 2, 3.
Oh, thank you.
Okay, any other questions? I will come to the class uh, like 10 or 15 minutes earlier. Like if our class is 9 a.m., I will come at something like 8:45 or 8:50. If our class is 9:05, I will come to the class something like 8:50 or 8:55. So I will come at least 10 minutes before our class time. So if you would like to start early, you can come early and then I will give you the exam so you can take more time. Like you can, uh, because some students need more time to think about the question. So this is why I will come to the class early, something like 10 minutes. So you can start early. Okay. Any other questions before I start?
Will the statistical tables be provided during exam or?
Yeah, it will be in the exam. So you need to write down your formula sheet and I will print out the any table you need at the end of the at the end of the exam. So if you need done it test, done it table, or you need T distribution table or any other table, I'll print it out and it will be at the end of the exam. Last page.
Okay, thank you.
Yeah, welcome.
Dr. Mahmood, I had a question. So, will the formula for, I mean, any formula that we need for the calculation would be given, like the confidence in interval formulas or any other formulas?
Okay. When I think about making a formula sheet, I see there are many formulas in this so far. So I'm not going to write down the formula sheet. So you can have your own formula sheet. So have a piece of paper or two pieces of papers, write down all the formulas you may need, any formulas, but there is no explanations, there is no definitions, there is no examples. Because if you have these three in the formula sheet, so it is lecture notes. So you write down all the formulas you need, but I'm not going to write, I'm not going to make a formula sheet for you. You can use your own one. Any other questions? Okay, let me start. I will go over chapter 1 up to chapter 3. Give me a minute or less. Do you see the whiteboard?
Yes.
Yes.
Okay, good. So let me start by chapter 1. Chapter 1, we covered in chapter 1 some statistical terms or some the things that is associated with design of experiments that is not associated with the other courses like Bayesian course or introductory course or whatever the course. Like observation study, experimental study, and observation units, experimental units, and so on. So in this chapter, we went over many things, like how do I count the number of experimental units in my experiment? What is the number of observation units in my experiment? How many treatments in my experiment? What do you mean by treatment factor? What do you mean by blocking factor? What do you mean by a control group? What do you mean by the main effect? And how do we calculate the main effect? How do we calculate and the meaning of the interaction effect? And also we covered many other stuff, like we covered the four fundamental principles. The four fundamental principles are for design of experiments, four fundamental principles of design of experiment, which are replication, randomization, blocking, blind, or double blind. So you need to be familiar with this one. You need to understand these ones in chapter 1. Nothing else. So you need to know how many experimental units in my study, how many observation units, how many treatments, how many treatment factors, how many blocking factors, what is the control group, what is the main effect or action effect, how do I calculate these ones? and also what are the 4 fundamental principles in design of experiments, which is replication, randomization, blocking, blind or double blind. Those 4 are very important, because if you have these 4 in your experiment, you have a very good experiment. Randomization, replication, blocking, double blind, or blind. For each one of these ones, there are some disadvantages, some advantages, and for design, like replication, we need replication to estimate the experimental error. We need randomization to avoid bias, and so on. So you need to be familiar with this one. So this is chapter 1. It's just terminology or statistical terms associated with the design of experiment. So you need to be familiar with these ones. Then chapter 2, if you have any question at any time, please stop me at any time and ask me your question. Just unmute yourself and ask the question. Chapter 2. This one is the simple comparative experiments. In simple comparative experiments, we covered 2 cases. We covered 2 independent samples and we covered 2 dependent samples. The 2 independent samples generalized in chapter 3, and 2 dependent samples will be generalized in chapter 4. So for 2 independent samples, we covered inference using confidence interval and test of hypothesis. For 2 independent samples, we covered inference using confidence interval and test of hypothesis. So whatever the case, you are working with 2 independent samples or 2 dependent samples, you need to be familiar with the assumptions, the statistical models, the graphical and numerical summary, the R output, and these kind of things. The inference is for what? Confidence interval or test of hypothesis is for what? For testing H0, that the 2 treatment means are equal versus the 2 treatment means are not equal, or mu1 greater than mu2 or mu1 less than mu2. For the 2 dependent samples, you are testing they are equal, which means the mu of the difference is 0, versus they are not equal means the mu of the difference is not 0 or greater than 0 or less than 0. It's based on what you are interested in. So for each case, or for each case of these 2 cases, you need to be familiar with many things. You need to be familiar with the assumptions of the t-test. For the 2 independent samples, the 2 samples are random samples and each group follows normal distribution. For the 2 dependent samples, the 2 samples are dependent samples, not independent, and the differences follows normal distribution. Is not each group follows normal distribution. The second case, you need to be familiar with the statistical model. And you need to be familiar with the graphical and numerical summary. It will be an R. I'm not going to ask you to calculate the graphical and numerical summary. It will be given in R using R, and then I will ask you about the output of R. And also you need to be familiar with confidence interval and test of hypothesis. In each case, and you need to be familiar with the R output. So maybe I give you R output, and then you can use this R output to calculate confidence interval or do test of hypothesis and so on. So let me go over these ones in details. Like the first case, two independent samples, the second case, two independent samples. What is the statistical model? What is the assumptions? What is the confidence interval formula, test of hypothesis, and so on. So I will go over these ones in details. So the first case, two independent samples. What are the assumptions? The assumptions are the two samples are random samples, independent and random samples. The second assumption is each group follows normal distribution. So normality for each group. The assumption, the statistical model is Yij equal mu plus tau I plus epsilon ij. And I is 1 or 2 because we have two treatments only. J is 1, 2 up to n. This is the statistical model. And then the R analysis, you should be R output. The R analysis, you should be familiar with this one. So if I ask any question about the R output, you should be able to answer it. What about the confidence interval? If you are working with two independent samples, the confidence interval is y1 dot bar minus y2 dot bar plus or minus t value at degree of freedom and alpha over 2. You find this one from the t distribution table. If you need it, it will be given times the square root of s1 squared divided by n1 plus s2 squared divided by n2. These values should be given. I'm not going to ask you to calculate the first sample mean, the second sample mean, the first variance, second variance. These ones will be given. And the t distribution will be given. So you should be able to find all these values. Keep in your mind the degree of freedom is the minimum between n1 minus 1 and n2 minus 1 because there are many formulas for the degree of freedom. We use this one because it is more safe. And then testing. The first step, H0, that mu1 equal mu2, H1, mu1 doesn't equal mu2 or greater than mu2 or less than mu2 based on what you are interested in. The second step is alpha should be given. Third step is the t value, which is y1 dot bar minus y2 dot bar divided by square root s1 squared divided by n1 plus s2 squared divided by n2. So all these values should be given, so you should be able to calculate T0. If I said follow the 5 steps, you need to write down the 5 steps. Do not calculate anything is given. If you calculate anything is given, you waste your time. For example, the p-value. For the p-value, it will be given. For any p-value, for anything, it will be given. I'm not going to ask you to calculate p-value because you need to use the applet or R or computer. So during the exam, I will not ask you to use the computer. So p-value will be given, and the last step, decision. Compare alpha and p-value and take your decision. If p-value greater than alpha, fail to reject. If p-value less than alpha, reject, and so on. So you take your decision. So this is the first case, and you should be able to test the normality. But this one will be given. Like if maybe I gave you some information about normality, like I gave you the QQ plot, I gave you Shapiro test output using R. If I give you these kind of things, you should be able to interpret these ones. Because if I said, is normality satisfied at 5% significance level? So you are not going to do by hand, like you are not going to graph the normal probability plot by hand or do Shapiro test by hand. The R output should be given and you should be able to use it. So if I said if normality is satisfied or not, you need to write down H0 and H1 for the Shapiro test, and then look at the p-value and take your decision, or you look at the normal probability plot and so on. So if there is something given, please do not calculate it. Otherwise, you waste your time. It's not my time. I'm not going to take the exam. So the first case. The second case is dependent samples. So please, if you have any question, let me know. Any questions so far? Okay, the second case is dependent samples.
Oh, Professor, can you just go back one more time? I just want to take a note on the last thing real quick.
Yeah, sure.
Thank you.
This one?
Yeah, just give me one second.
Take your time.
Okay, thank you.
You're welcome. The two dependent samples, the assumptions are the normality for differences, not for each group. And the second one, dependent samples. You have two groups of data, and you measure one sample 2 times. So this is the assumptions. The second assumption is, the statistical model. The statistical model is Yij equal mu plus tau I plus beta j. This is a new guy to the model. Plus epsilon ij. Mu is the overall mean. Tau I is the effective treatment I. Beta j is the effective block j, or the individual j, or the subject j. And I is 1, 2, because we have only 2 treatment. J is 1, 2, up to n. This is a statistical model. And again, you should be familiar with the graphical summary and numerical summary that is from R. I'm not going to ask you to graph a plot during the exam or calculate numbers during the exam, calculate the numerical summary during the exam. But you should be able to use these ones if I asked you to calculate anything. Like you can use this numerical summary to calculate a confidence interval or do test of hypothesis. So for example, if you are going to calculate a confidence interval, you should use this formula. D bar plus or minus t value at degree of freedom and alpha over 2 times the standard deviation of the differences divided by square root of n. I'm not going to ask you to calculate d bar or sd or n because these values take much time. It should be given, and you should be able to calculate these ones, and you should be able to find the t value from the table, and keep in your mind the degree of freedom is n minus 1, number of values minus 1. If the lower limit is negative, upper limit, like the previous one, this one, in this confidence interval, in general, in any confidence interval, if the lower limit is negative, upper limit is negative, reject H0. Lower limit is positive, upper limit is positive, reject H0. But if the lower limit is negative, upper limit is positive, you fail to reject H0. This is general for any confidence interval. And if you'd like to do testing, to test H0, that mu d is 0 means on average the difference is 0. It means the two treatments are equal. H1, mu d is not 0. It means the two treatments are not equal or greater than or less than 0. This is the first step. Second step, alpha should be given. Third step is T0, which is d bar minus mu d, which is always 0, divided by the standard deviation of the differences divided by square root of n. And then you should be able to find the p-value, but in the exam paper is not using applet or calculator, because this one should be given in the exam. The fourth step, compare p-value and alpha and take your decision. The two treatments are equal or the one of them is greater than the other or they are not equal. So testing the assumptions, again, the information will be given, like I will give you the QQ-BLAT or I gave you the Shapiro test output to test the assumption. Any question about chapter 2? Any question about chapter 2? Okay, let's start chapter 3. Chapter 3, this one is experiments with one treatment factor. Experiments with one treatment factor. You have one treatment factor, but it has many levels. So we generalize the two independent sample case in chapter 2. So we have only one treatment factor. It has many levels, like level A, level B, level C, level D. And each will receive some experimental units randomly. So this one is called the complete randomized design. Complete randomized design. So in this chapter, you should be familiar with the assumptions. We have 3 assumptions. The first one is independent samples or independent observations or independent residuals. The second assumption is constant variance. The third assumption is normality. For each one of these assumptions, there is a graph and a test. So independent, you look at the graph of number, the residual order or the order of the residual versus the residual value. And the test is Durbin-Watson test. Constant variance, you look at the fitted versus residual blood, and the test is Levine test. Normality, QQ-BLAT, and the test is Shapiro test. We cover these tests, but there are many tests. But these are a famous one: Durbin-Watson test, Levine test, and Shapiro test. And you should be familiar with the ANOVA test, ANOVA table that will be given by R. I'm not going to ask you to calculate the numbers inside this table. It takes much time. And this ANOVA test is used to test H0, mu1 equal mu2 equal up to equal mu A versus H1 is at least 1 is different. And you should be able to know the statistical model. And you should be able to check the assumptions. Given the output, I'm not going to ask you to calculate anything like Shapiro test or Levine test. Or you should give you the output by R, and then you should be able to check the assumptions. And if we rejected H0, if we rejected this guy, it means at least 1 is different. So you do multiple comparisons. Why you do multiple comparisons? Or why we do not use t-test for multiple comparison to test H0? That mu I equal mu J versus H1, mu I doesn't equal mu J. After we reject H0, we need to know which ones are different. So you can use H0 as mu I equal mu J versus H1, mu I doesn't equal mu J. And I equal 1 up to J, up to A, and I doesn't equal J. So can I use t-test for each one of these ones? You shouldn't do it because alpha get inflated. So do not use t-test like in chapter 2. for each one because alpha overall get inflated. And we practiced how to calculate the alpha overall or the overall significance level, and we found the overall significance level is greater than 5%. Sometimes it will be very close to 1. It means almost sure you will commit type 1 error, in at least one of these tests. So this is why we have some recommended solution for this problem. We have Pamforoni, we have Tukey, we have Dunnett, and we have Fisher. So each one of those guys has some contribution, or each one of those guys recommended some solution. So let me go over these ones in details. So the statistical model, and now you know the assumption and how to check the assumptions. You should be familiar with the ANOVA table and the relationship between the numbers, and you should be able to use the p-value in the ANOVA table to test H0 mu1 equal mu2 up to mu a versus at least one is different. And the statistical model is like the one in chapter 2, which is yij equal mu plus tau I plus epsilon ij. But the only difference between chapter 2 and chapter 3 is I equal 1, 2, 3 up to a. In chapter 2 it is 1, 2 only. And j is 1, 2 up to n, like chapter 2. Check the assumption. I talked about this one. Multiple comparison. Pamforoni, Tukey, Dunnett, Fisher. This one is the least conservative, and this one is the most conservative. This is why these two guys are very famous ones. So let me go over these ones in details. The first one is Pamforoni. What is the contribution of Pamforoni to test H0? Mu I equal mu j versus H1, mu I doesn't equal mu j. He said reject H0 if the absolute difference between any two treatment means yi dot bar minus j dot bar is greater than this value. Find this value from the t distribution table at big N minus a and alpha over 2c. What is c? Is the number of tests you are interested in. Maybe you are interested in comparing all of them. Maybe you are interested in some specific tests like 3 or 4 or 5 or only one, times the square root of MSE from the ANOVA table times 1 divided by Ni plus 1 divided by Nj. If they are equal, Ni equal Nj, it will be 2 divided by N. So this one works whatever the design is balanced design or unbalanced design. So he said reject if the absolute difference greater than this value, and fail to reject if it is less than this value. And also he said you can calculate a confidence interval for the difference between mu I and mu j. You can calculate this confidence interval, lower limit and upper limit, using this simultaneous confidence interval formula. yi dot bar minus yj dot bar plus or minus t value at big N minus a, or the degree of freedom of error from the ANOVA table, and alpha divided by 2 c times square root of MSE times square root of 1 divided by Ni plus 1 divided by Nj. If the lower limit is positive, upper limit is positive, you reject. Lower limit is negative, upper limit is negative, you reject. Lower limit is negative, upper limit is positive, you fail to reject. So you can use this confidence interval for testing also. So the contribution of Pamforoni is dividing the individual significance level by 2c. So the individual significance level divide alpha by c, sorry. So the individual significance level for Banfroni is c divided by, alpha divided by c. Alpha divided by c is not alpha. Alpha, sorry, divided by c. Alpha divided by c. This is the individual significance level, and we hope the overall significance level is 0.05 or 0.01. This is the individual, and this is the overall significance level. And C is the number of pairwise differences you are interested in, or number of tests you are interested in. Any questions so far, guys? So this is Banfroni. The second guy is Tukey. Tukey method. This guy said to test H0 mu1 mu I equal mu j versus H1 mu I doesn't equal mu j, use this formula. Reject H0 f the absolute difference between yi dot bar and yj dot bar is greater than some value from the Tukey table. Some value from the Tukey table. How do I find this value from the Tukey table? Q alpha at overall significance level alpha. How do I find this value from your table? He said find A, the number of treatments, first column, and F, the degree of freedom. F first column. This one is first column, and this one is first row in my table, and you find this alpha. So find this Q value. What is F? Is the degree of freedom of error, n minus A. And what is A? Is the number of treatments in your experiment. Find this value from the table and multiply by square root of MSE from the ANOVA table, divide by number of experimental units assigned to each treatment, or number of replicates, n. Reject if this one is greater than this one, and fail to reject if it is less than. So the only contribution he has is this value. He said do not use T value, use my own values from my own table. And if you need this table, it will be printed out with the exam. Can I test H0 mu1 equal mu j versus mu1 doesn't equal mu j using a confidence interval? Using the Tukey method, you can do it. The formula for the confidence interval for Tukey is y, simultaneous confidence interval for Tukey is yi dot bar minus yj dot bar plus or minus Q value at overall significance level alpha, A and F from the table times the square root of MSE divided by n. If the lower limit is negative, upper limit is negative, reject. Lower limit is positive, upper limit is positive, reject. Lower limit is negative, upper limit is positive, fail to reject. So this is the contribution of Tukey. He used his own table. He came up with a table, and he said use the values in my table, do not use the values from the T distribution table. And this one achieved the overall significance level 5%. So alpha will not get inflated to be more than 5%. So this is the second method. The third method is Dunnell method. He said to test H0 mu I equal mu A. What is mu A? He said this method, my method, should be used if you have a control group. if you have a control group, do not use this method when you are comparing all the treatments. Use this method only to control all the treatments to the control group, assuming it is mu A. So you test H0 mu I equal mu A versus H1 mu I doesn't equal mu A, and I is 1, 2 up to A minus 1. So reject if the absolute difference between yi dot bar and ya dot bar greater than some value from his table d alpha at overall significance level equal alpha. How do I get this value d alpha? You go to the table and find a minus 1 first row and f degree of freedom of error first column, and the intersection is the d value. Multiply this value by the square root of MSE times 1 divided by Ni plus 1 divided by Na. Is this value greater than this one? Reject. If it is less than, fail to reject. So what if I want to use the confidence interval? You replace this one by plus or minus. The last one is Fisher. Fisher said, I'm not going to change anything. To test H0, that mu I equal mu J versus H1, mu I doesn't equal mu J. Reject if the absolute difference between yi dot bar and yj dot bar greater than the t at alpha over 2 and the degree of freedom big N minus A times square root of 2 MSE divided by N. But you didn't change the t distribution. The alpha will get inflated. He said alpha will not get inflated much if the design is balanced design. So use this one when the design is balanced design. But this one is the least conservative. You shouldn't use this one actually, unless you didn't get any significant results and you'd like to publish a paper. So you can use Fisher, but the design should be balanced design. If you have a very good data set, you use Baum-Frohny. It is very conservative. But usually people use Dunnett if you have a control group, Tukey if you do not have a control group. So far, so good. Okay.
Yes.
Thank you. So, and then we covered something called contrast. So what do you mean by contrast? Contrast is a linear combination of the treatment means. If we have A means like mu1, mu2, up to mu A, because we have A treatments. If you multiply it each by some number and take the sum, it will be a linear combination, like sum of Ci times mu I, and I equal 1 up to A. So if you multiply mu1 by some number, mu2 by some number, mu3 by some number, up to mu A by some number and take the sum, this is called a linear combination. So, and this linear combination is a contrast if the sum of Ci is 0. This is very important. If sum of Ci is 0, this is contrast. If the sum of Ci is not 0, this is not a contrast. So let me give you an example. If H0, if you have a research question, like I would like to know mu2 equals the average of the other 3 treatment means, like mu1 plus mu3 plus mu4 divided by 3, or mu2 doesn't equal mu1 plus mu3 plus mu4 divided by 3, sorry. So how do I test this one? If this one is a linear combination and the sum of Ci is 0, this is a contrast, can be tested, and you can calculate confidence interval. So you can write this one as mu2 minus 1/3 mu1 minus 1/3 mu3 minus 1/3 mu4 equals 0. So this one can be written as sum of Ci mu I equals 0. C1 is 1. The value next to mu1. So this one, C1 is negative 1/3. C2 is 1. C3 is negative 1/3. C4 is negative 1/3. So this one is a linear combination of the treatment means it is a contrast, and I can write it down as C equals 0 if the sum of Ci is 0. So let's see the sum of Ci is 0 or not. C1 is negative 1/3 plus C2 is 1 plus C3 negative 1/3 plus C4 negative 1/3. The sum is 0, so it is a contrast. So this linear combination is contrast. If it is a contrast, I can test this one. I can calculate a confidence interval. So how do I calculate confidence interval for C? Or how do I test C? So let's cover testing first. I will test H0 C equals 0, which means mu2 equals the average of the other three, versus H1 C is not 0. The second step, alpha should be given. Third step, you standardize C hat. What is C hat? C hat is the estimation of this contrast. The contrast is sum of Ci mu I. So the estimation of this contrast is sum of Ci times Yi dot bar, because Yi dot bar is the estimation of mu I, and Yi dot bar should be given. So like Y1 dot bar, Y2 dot bar, Y3 dot bar should be given, and Ci should be known because you should know these C1, C2, C3, C4, so you can estimate C hat. And then so T0 is C hat minus the C value that is in the null hypothesis, so it is 0 divided by square root of MSE from the ANOVA table divided by little n, number of experimental units assigned to each treatment, times sum of Ci square. So when you calculate, this one is not sum of Ci, you need to calculate sum of Ci square. So this one is sum of Ci square is C1 square plus C2 square plus C3 square up to the last one, Ca square. So you square the C values and then you take the sum. The fourth step, p-value. It will be given in the exam. You don't need to calculate this p-value. Any p-value, it will be given. And the last step, take your decision. Compare p-value to alpha and take your decision. This is if you want to know H0 is correct or H1, which one the data support H0 or support H1 using test of hypothesis or testing. But if you'd like to do testing using a confidence interval, so the confidence interval for the contrast is C hat plus or minus T value add degree of freedom and alpha over 2 from the T distribution table times the square root of MSE from the ANOVA table divided by little n times the sum of Ci square. What is the degree of freedom? Degree of freedom for error, big N minus A. And alpha should be given, you divide by 2, and then you should be able to find the T value from the T distribution table. If you need the T distribution table, it will be given in the exam. I will print it out. Okay, any questions so far? I forgot to say, you can test C equals 0 versus doesn't equal or greater than or less than. How do I use the confidence interval? If the lower limit is negative, upper limit is negative, reject, positive, reject, negative, positive, fail to reject. Any questions so far?
Yes, I have one question.
Sure.
For both this confidence interval and for testing the significance level, at first we calculate the contrast, calculate whether it is a contrast or not, and then if it's not a contrast, then we don't go further, right? Or
Yeah, correct.
okay. So yeah, in homework, question number 4, I did not understand 4C. It says test at 1% significance level whether this contrast in B is different from 0. So
So it
it
means
will
you
be
are testing this one versus this one.
okay, but there is question number B as well, and in B it's 0, so it will also be 0 in C, right? So will it be different since nothing else is given here? I was confused
You
with
mean
this
nothing
question.
else given as output?
Yeah. Uh, it says like in question number 4B, it says calculate 95% confidence interval of the contrast and control average is equal to average of two treatments. And then when we calculate the contrast, this is not a contrast in question number 4B. And in 4C, it says test at 1% significance level whether
So
this
it means you
contrast.
found, does it mean you found it is not contrast and then I asked you to calculate a confidence interval, do test of hypothesis?
Yes.
Oh, double check because if it is not contrast, I
Mhm.
shouldn't ask you to do confidence interval or test of hypothesis. So double check the
Okay.
contrast, it is contrast or not. Because
Okay.
if I
So,
said
mhm.
calculate a confidence interval or do test of
Mhm.
hypothesis, so for sure it is a
Mhm.
contrast.
Okay. So,
Otherwise, if you are sure it is not a contrast, you shouldn't
mhm.
calculate confidence interval or do test of hypothesis.
Okay. Thank you.
You're welcome. Any other questions? Okay, so this is the contrast, and then we covered the random effect model. Random effect model. The random effect model is Yij equal mu plus tau I plus epsilon ij and I equal 1 to up to A and j equal 1 to up to n. But this is the same model. Yeah, the same model, but how do you look at these tau i's? This is fixed effect or random effect. If you are interested in these specific A treatments, this is fixed effect. But if you consider these A treatments are or A levels are random sample from all the possible levels, so this one is random effect. So now you have in the model two random effects. This one and tau I. So this one should follow normal distribution with mean sigma square, and this one should follow normal with mean 0 and sigma tau square. So you have two variance components you are interested in, and estimating these two, sigma square and sigma tau square. So in this case, the random effect, I am not interested in testing H0, that mu1 equal mu2 equal mu3 up to mu a versus at least one is different. I'm not interested in these A treatments. I'm interested in all the levels. So you write H0 as sigma tau square is 0 versus sigma tau square is not 0. This is the correct one. This is not correct one. Because I'm not interested in A treatment means. I'm interested in all the levels. So all the levels are equal. It means the variability between treatments is 0. At least one is different. It means the variability is not 0. So if in random effect, I'm interested in estimating sigma square is what? Sigma tau square is what? I'm not interested in estimating mu1, mu2, mu3, mu4 up to mu a. I'm interested in estimating the two variance components. And also, I'm not interested in testing mu1 equal mu2 up to mu a. I'm interested in testing H0, sigma tau square is 0 versus sigma tau square is not 0. So you can use the p-value in the ANOVA table to reject or fail to reject. I'm not going to use the p-value in the ANOVA table to test this one. I'm going to use the p-value in the ANOVA table to test this one because I'm not interested in these A treatments. I'm selecting A levels to make conclusion about all the treatments or all the levels in the population. So how do I estimate sigma square? This is MSE. How do I estimate sigma tau square? This is MS treatment minus MSE divided by little n. So this is how to estimate the variability due to treatments, how to test the variability between treatments. Any questions so far? But the ANOVA table will be the same. The ANOVA table will be the same ANOVA table. No numbers changes. So the sum of squares, degree of freedom, mean square, F value, P value, they are the same. Like you have three numbers here. This is the total. You have three numbers here. You have two numbers here. You have one number here. You have one number here. You can use these two numbers to estimate sigma tau square. You can use this number to test the sigma tau square. But the numbers are the same. How do I calculate the numbers? The same. The last thing we covered in chapter 3 are the power analysis. It is a long chapter.
Professor, can you go back? I have a quick question about the last slide.
Sure.
Yeah, so the one next to degrees of freedom, is that MS, like mean square?
This is the mean square, yeah.
The mean square. But the mean square, do we divide it by sum of square to get the F value or not?
You divide this one by this one. So 1 divided by 2. It gives me mean square. So you divide this value by this value by this value.
Okay. So the mean square, like you get it separately from F value, like with the value of mean square.
Yeah, the F value is this one divided by this one. So you divide this one by this one, you get this one.
Okay, so M square 1 divided by M square 2.
Very good. If you call them M square 1, M square 2, or MS1, MS2.
Okay, thank you.
You are welcome. Any other questions? Okay, the power analysis. The idea of the power analysis is if you have 4 treatments like treatment A, treatment B, treatment C, treatment D, how many experimental units should be assigned to each treatment? How many? 4, 5, 7, 10? How many? So we need to know N is what. How do I get N? There are many factors determine N. The first one is the significance level. You as a researcher, you should select significance level because 5% give you different number compared to other one. So 5% is different from 1%. It gives you different N. And second thing is the number of treatments. The number of treatments you have determine N. The third one is the power. The probability of rejecting H0 that says mu1 equal mu2 up to mu A. I would like to reject this one when it is incorrect in the population. So the probability of rejecting this one when it is incorrect should be big number, and this is the power. So you should use a big value like 0.8, 0.9, 0.95, or 0.96, any number greater than 0.8, but some people use less than this one based on your resources. Maybe you do not have much resources. The last one is the effect size. The effect size. This one, there are many ways to calculate the effect size, but there is a function in R, it's called Cohen.es, if I remember. And this one recommend 3 values. You can use this, it recommends some value if you are going to use a small size effect. And another value if you use medium size effect. And another value if you use large size effect. So for our example, like for For ANOVA, this value is 0.25. So if you use this value and this value and this value, it gives you some specific number of experimental units assigned to each treatment, or you can see it as number of replicates. So this is chapter 3. Any question? I'm done. Questions? If you do not have any questions, so I have to say goodbye and see you in the exam. Hello. Any questions?
I have one last question. I know you
Sure.
went through it already, but I'm still confused on it. Like how to calculate the contrast. So suppose like if the control average is equal to average of two treatments, suppose like 1/2A is equals to 1/2 in bracket B plus C. So it will
Okay,
be
so let's go
1/2.
back to the contrast.
Okay,
This,
thank you.
this one?
Yes, yes.
So how do you
So,
estimate the contrast?
so
Okay.
like in a particular situation, I'm talking about a particular situation where the average of one treatment is equal to average of two other treatments.
Okay.
Mhm.
Other two treatments?
Yes, average of
Okay.
one
So
treatment
let's
is
have an example. Okay, good.
okay.
So
Mhm.
the H0 is mu1 equal mu2 plus mu3 divided by 2, isn't that?
No, it's like average of mu1 is equal to average of mu2 plus mu3.
This one?
When it says like average of mu1, shouldn't it be like mu1 divided by 2? Yeah, I'm confused in this exactly, like not
Because
exactly how to
if you,
calculate it, but like what's
so
the
first, how many
language?
treatments you have? How many treatments you have?
Uh, we have three means, mu1,
Okay,
mu2,
mu1,
mu3.
mu2, mu3.
Mm-hmm.
So you are
And
interested
then
in testing mu1 equal the average of the other two, or
in the
something else.
question, it's like I understood like this in the question, but in the question it's like average control is equal to average of two other treatments. So shouldn't
Okay,
it be like
average control equal the other, I think there are two treatments, I think.
mm-hmm,
So mu treatment 1 plus mu treatment 2 divided by 2. This is the average of the other two treatments, the sum of two values divided by 2. The average of the three, the sum 3 divided by 3. The average of 4, you sum 4 values divided by 4, and so on.
okay, I
So this one
understood
should
now.
be H0.
Mhm. Okay, I was thinking because of the language, maybe average control would be like mu control divided by 2. So I was confused because of the language.
Oh, got it. This one is called the average
Uh-huh.
of control.
Okay, okay,
And
now
this
I
is
got
the
it.
average of the other two averages.
Okay,
Like the
now I got it.
average
Thank you.
of the other two treatment. So
Mhm.
the treatment, mu treatment plus mu treatment. This is my bad, sorry.
Okay, thank you
So
so much. I was
you are
confused
welcome.
because of yeah.
No, it's okay. It's fine. Any other questions?
Professor, before you end the call, do you mind going back? I want to just take the note from
Yeah, sure.
the one
Which
after
one?
Turkey. I think you went
The
over
one after
Bonfroni, Turkey, and Dunnett. Can you go
done
back to the
this one?
slide?
This is done it. So you need this one or the next or previous one?
Yeah, this one. Just take a
Okay,
second.
take your time.
And then one last thing, I think in the beginning there was let me just see real quick. When you did the chapter 2 simple comparative experiment, you talked about the assumption of the t-test, statistical model, graphical and numerical summary, and then there was a fourth one.
This one, fourth one is confidence interval and test of hypothesis.
Okay. Okay, yeah, I get it. Thank you.
Okay. You're welcome.
Can you go back to slide 1, please?
Yeah, sure.
Okay, I'm good. Thank you.
You're welcome. Any other questions?
Could you go to the slide with Donitz and Fishers on it?
Fisher? Okay. Where is Fisher? This one? Fisher?
So the parameter A minus or A minus, well, that's it's the number of treatments minus the control group. But what was that second parameter F?
You mean for Fisher? Where is F? I do not see
Sorry
any
for
F.
Donitz. For Dunnett, that's my
For
bad.
Dunnett, okay, for Dunnett, this one is a degree of freedom of error, which is big N minus A. It is the same thing, this one actually, but he gave a different notation. Like he doesn't use N minus big N minus A, he used F. What is F? The degree of freedom of error.
Okay, thank you.
So A is the number of treatments, F is the degree of freedom for error in the ANOVA table. Any
Okay, thank
other
you.
questions? You are welcome. Any other questions?
I have one question
Sure.
for T distribution table. Like if our degrees of freedom is 47, but in T table we have the value for 40 and 50, then which one I should take for
Where is the
47
degree
degrees
of
of
freedom
freedom?
equal? Degree of freedom equal what?
Like 47. I
47.
need, yeah, from T distribution table I need p value, but in table we have like value for 40 and 50, not for 47.
So
Then,
first you don't need the p-value, you need the t-value.
oh, sorry, T value,
At
yeah.
degree of freedom and alpha over 2. Okay, because yours is in between. So if you'd like to use the table, you can use something like if there is this is the value and this is the value, you can see some people use like 40 divided by 47 equal this value divided by this value, or cross multiplication, or some people use some specific value. Or you can use the smaller one, because this one is more safe to work with. You
Thank
can
you.
use degree of freedom equal 40. But actually nowadays we have computers, we have advanced calculators, we have applets. So you can use advanced calculator or R or whatever to get the exact t value. But these tables, they were using this one long time ago, but they still use it. But actually, if you need some value and it is not listed at the degree freedom you have, you should use R or advanced calculator or any other software to get the exact value for t nowadays,
Okay.
because we have computers nowadays. But these tables are very old tables, so we should use it for some degree freedom is not listed.
Okay, thank you.
You are welcome. Any other questions? Okay, have a great weekend. Thank you.
Thank
So
you.
you too. Have a great weekend.
Thank you, Professor. Have a
You
good one.
too.
Thank you,
Thank
Professor.
you. Have a good one.
Professor.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.